Hello dear students, hope you all are fine. We are almost coming to end of the chapter solid state. Okay, so today we will discuss about the electrical properties of solids. Okay, we all know solids exhibit amazing range of conducting properties. Okay, so based on the conductivity property, the solids are classified into three types. Which are they? Generally, solids have a conductivities in the range between 10 raised to minus 20 to 10 raised to 7 ohm raised to minus 1 meter inverse. Okay. So, based on this conductivity range or based on the conductivity properties, solids are classified into three types. Which are they? First one is conductors. Conductors means which are good conductors of electricity. That is, their conductivity range is in between 10 raised to 4 and 10 raised to 7 ohm raised to minus 1 meter inverse. Okay. And if we have the conductivity 10 raised to 7 ohm inverse meter inverse, then that such type of solids are called good conductors. Okay. So, and the second type is insulators. Insulators means we all know they have very low conductivity power. That means their conductivity value will be very low. Okay. So, their range will be 10 raised to minus 20 to 10 raised to minus 10. Such type of materials or solids are called insulators. Okay. Then one more category is there, that is semiconductors. Their range will be in between the conductors and insulators. That is, the range of conductivity will be 10 raised to minus 6 to 10 raised to 4 ohm raised to minus 1 meter inverse. So, these conductivity values, the solids classified into three categories. So, that is all about their conductivity property. Okay. Our next topic is conduction of electricity in metals. You know, the metals conduct electricity through movement of electrons or through the movement of ions, isn't it? Okay. So, movement of ions in example is metallic conductor. Metallic conductor can get the conductivity through the movement of electrons. Okay. Ions in the movement and conductivity in example are electrolytes. Okay. So, like the way they are getting conductivities. Okay. So, metals conduct in solids as well as in solids metal conduct solid state as well as its molten state. Okay. And also one more point, depends upon the number of valence electron. Their conductivity depends upon the number of valence electron. So, the atomic orbitals combines with the molecular atomic orbital combine to form molecular orbitals, both having the energy same energy range. Okay. So, valence electron partially filled ആണെങ്കിൽ അല്ലെങ്കിൽ valence band partially filled ആണെങ്കിൽ electrons will move to the conduction band അല്ലെങ്കിൽ അവ തമ്മിലുള്ള overlap ഉണ്ടാവും. Okay. So, partially filled valence band can overlap with the unoccupied conduction band. Such type of solids are called conductors. Why they are called conductors? That is, they are overlapped in nature. That is, both valence band and conduction band overlap each other. So, the electrons from the valence band can easily jump into the conduction band, isn't it? So, because they are very close each other, so electrons in the valence band electrons filled ആണ്, but conduction band unoccupied ആണ്. അപ്പോൾ ഇവിടെയുള്ള electrons easily jump ചെയ്യാൻ കഴിയും because they are overlapped each other, so that conductivity is more. Such type of materials are called conductors. So, conductors the gap between valence band and conduction band is very small. അല്ലെങ്കിൽ gap ഇല്ല എന്ന് പറയാം നമുക്ക് അല്ലേ. Then one more type, if valence bandും conduction bandും തമ്മിൽ more gap ഉണ്ടെങ്കിൽ എന്താ സംഭവിക്കുക, valence band in the electrons cannot jump into the conduction band. So, conductivity will be very less. അല്ലെങ്കിൽ conductivity ഉണ്ടാവില്ല. They cannot jump. The electrons in the valence band cannot able to jump into the conduction band. So, we know conductivity is possible only by the movement of electrons. Okay. Here the movement impossible. The region is forbidden or energy gap between these two is very large. Such type of materials are called insulators. ഇനി one more type ഉണ്ട്, നമ്മൾ എന്താ പറഞ്ഞാൽ സെമി കണ്ടക്ടേഴ്സ്. സെമി കണ്ടക്ടേഴ്സിലും വാലൻസ് ബാൻഡ് ഉണ്ടാവും, കണ്ടക്ഷൻ ബാൻഡ് ഉണ്ടാവും. ബോത്ത് വാലൻസ് ബാൻഡ് ആൻഡ് conduction band. Here what will happen? The energy gap will be very small and some electron energy gap ആണ് ഇത്. So energy gap will be very small. അപ്പോൾ എന്താ സംഭവിക്കുക? Conductivity will be very small. Conductivity ഇവിടെ conductivity high ആയിരിക്കും കാരണം ഏറ്റവും ക്ലോസ് ആണ്. Such materials are called conductors. Then the energy gap very high ആണെങ്കിൽ അതാണ് നമ്മൾ പറയാ insulators. Then if the gap between conduction band and valence band is very small, such materials are called semiconductors. Semiconductors. Their conductivity will be very small or conducting power will be very small. How will you increase the conducting power of semiconductors? By increasing the temperature. നമ്മൾ ചൂടാക്കി കഴിഞ്ഞാൽ കുറച്ചുകൂടി conducting powers കൊടുക്കാൻ പറ്റും. How? Because electrons in the valence band can jump into the conduction band. Thus we can increase the conductivity of semiconductors. That is, by increasing the temperature we can increase the conducting power of semiconductors. Okay? Or otherwise we can increase by adding impurities. Okay, so the conducting power of semiconductors we can increase by adding impurity. That process is known as doping. What does mean by doping? That is, increase the conducting power of or conductivity of semiconductors by adding certain impurities are called doping. Okay. So I told you, by increasing the temperature we can increase the conductivity of semiconductors. How? By increasing the temperature, electrons in the valence band can jump into the conduction band. Such types of semiconductors are called intrinsic semiconductors. Okay. Another method for increasing the conductivity is by adding the impurity. So that process is known as doping. What does mean by doping? The conductivity of semiconductors is increased by adding certain impurity is called doping. Okay, so how will you dope? നമുക്ക് എങ്ങനെ ചെയ്യാം ഡോപ്പിംഗ് എന്ന് നോക്കാം. നമുക്കറിയാം, I told you for intrinsic semiconductors എക്സാമ്പിൾ ആണ് സിലിക്കൺ, ജെർമേനിയം എക്സെട്ര. സിലിക്കൺ, ജെർമേനിയം ഒക്കെ എന്താണ്? സെമി കണ്ടക്ടേഴ്സ് ആണ്. They belongs to group 14th. Group 14th element ആണ് സിലിക്കണും ജെർമേനിയം. Okay, so group 14th element സ്പെഷ്യാലിറ്റി എന്താണ്? Group 14th element have 4 number of valence electron. So that means they can form 4 covalent bond using that 4 valence electron, isn't it? Yes. So when you dope with this group 14 element like silicon, germanium, you dope with groups like 15th group. Suppose phosphorus, arsenic, etc. Group 15th. When you dope with this silicon or germanium, what will happen? Phosphorus group 15th we have 5 number of valence electron. Okay, then 4 covalent bond form ചെയ്ത് കഴിഞ്ഞാലും we will have a 1 electron extra അല്ലേ. So ഒരു additional ആയിട്ട് ഒരു single electron ഉണ്ടാവും. Delocalized single electron is there. Addition to the 4 covalent bond form ചെയ്ത് കഴിഞ്ഞാലും neighboring അറ്റത്തിൽ ഒരു electron അഡീഷണൽ ആയിട്ടുണ്ടാവും. സോ എക്സ്ട്രാ 1 ഇലക്ട്രോൺ പ്രസൻ്റ് ആയിരിക്കും ആ സൈറ്റിൽ. സിലിക്കണിൻ്റെ സൈറ്റിൽ നമ്മൾ ഇമ്പ്യൂരിറ്റി ആയ നമ്മൾ ഡോപ്പ് ചെയ്യാൻ ഏതാണോ യൂസ് ചെയ്ത ഗ്രൂപ്പ് 15th element will occupy at the any site of the silicon and 1 electron is excess there. So that create a negative charge to that semiconductor. Such type of semiconductors are called n-type semiconductor. Okay. So n-type semiconductor means that group 14th elements, that is semiconductors, we can dope with using group 15th elements like phosphorus or arsenic. Then what will happen? There existed additional 1 electron excess. So it create a negative charge hole. So that type of semiconductors are called n-type semiconductor. Okay. Suppose we are doping the group 14th element like silicon or germanium with the group 13th element. Okay, what will happen? Group 13 means we have only 3 valence electron available there. Okay, so 1 electron less ആണ്. ഇവിടെ നമ്മൾ electron rich compounds, doping semiconductors with electron rich compound ആണ്. Then we will get the n-type semiconductor. Okay, so if we are doping that semiconductors with electron deficient compounds such as group 13th element, then what will happen? We need 4 electrons, isn't it, for forming 4 valence bond, but we have 3 bond form ചെയ്യുള്ളൂ. എന്തുകൊണ്ടാണ്? 1 electron shortage ഉണ്ട്. So 1 electron shortage ഉള്ള സ്ഥലത്ത് it creates a hole, അല്ലെങ്കിൽ it will have the effect of positive charge. So what will happen? ആ ഹോൾ ക്രിയേറ്റ് ചെയ്യുമ്പോൾ ആ ഹോൾ ഫില്ല് ചെയ്യാൻ വേണ്ടി ഓട്ടോമാറ്റിക്കലി നൈബറിങ് ആറ്റത്തിൽ നിന്ന് ഇലക്ട്രോൺസ് ഇങ്ങോട്ടേക്ക് വരും അല്ലേ? സോ സപ്പോസ് ഇവിടെ ഒരു ഹോൾ ക്രിയേറ്റ് ചെയ്ത് നൈബറിങ് ഇതിൽ നിന്ന് ഇലക്ട്രോൺസ് ജമ്പ് ചെയ്യും ഈ ഹോളിലേക്ക്. സോ ഇവിടെ ഇലക്ട്രോൺ ഫില്ല് ചെയ്യും, ദെൻ ജമ്പ് ചെയ്ത ഭാഗത്ത് വീണ്ടും ഹോൾ ക്രിയേറ്റ് ചെയ്യും. So that process will taking place. So what will happen? The direction of electron jump will be right ആണെങ്കിൽ the creation of hole എന്തായിരിക്കും? Opposite direction ആയിരിക്കും. So like the way this process is going on. Okay, so the direction of electron jump will be opposite to the direction of the creation of the hole. Okay, so such type of semiconductors are called p-type semiconductor. Okay, so we have, while doping we have 2 possibilities, that is dope the silicon with electron rich compound, or we can dope it with the electron deficient compound. If we dope it with electron rich means we will get a single electron extra, that means we will get a negative charge effect. Such type of conductors or semiconductors are called n-type semiconductors. N negative nalla n-type semiconductors. Okay, then if we dope the semiconductor with electron deficient compounds means overall a hole creates. Okay, so that means a positive effect ആണ് അവിടെ ഉണ്ടാവുക. So such type of semiconductors are called p-type semiconductors. Okay, next, uses of semiconductors. What are the different types of uses? We know we are using diodes, right? What is diode? It's a combination of both n-type and p-type semiconductor. A lot of physics experiment you might have used the diodes, isn't it? So which is the combination of n-type and p-type semiconductors. Then next, transistors. Okay, transistors means sandwiching a layer of semiconductors in between other in between 2 layers of other semiconductors. Okay, that means example edukya NPN transistor, PNP transistor, രണ്ട് n type inde idakku oru p type, that is sandwich ചെയ്തിരിക്കുന്ന structure. So such type of structure is called transistors. Next application ആണ് solar cells. Solar cells means efficient photodiode ആണ് solar cells. Solar cells ന്റെ function എന്താ? It converts light energy to electrical energy. So these are the uses of semiconductors. Okay, and using this method doping we can prepare variety of compounds. ഇപ്പോൾ നമ്മൾ പറഞ്ഞ കേസ് ഏതൊക്കെയാ? Group 14 elements doped with 15 or 13th element, that is p type and n type, and other varieties also possible. We can dope with group 12 and 16. So example of here, the example gallium arsenide, the example of 14th, and phosphorus arsenic means 15th. അത് രണ്ടും ഡോപ്പ് ചെയ്തതാണ്. So some examples are group 12, 16 ഡോപ്പ് ചെയ്ത examples ആണ് ZNS, CDS, HGTE, etc. So like that we can prepare variety of compounds. For example, transition metal oxides we can prepare by doping. Example, rhenium ReO3, which is same as that of by appearance, which is same as that of metallic copper. Or we can prepare by doping that is vanadium oxide, variety of oxides of vanadium. Okay, so these are the uses and properties of semiconductors. Okay, so next is magnetic properties of solids. So we know every substance have a small magnetic property in it. Every substance behaves like a magnet. Little magnetic property will be there in every substance. Why it is so? Because the presence of electrons, right? So origin of this magnetic property is electrons, isn't it? So each electron in a substance behaves like a tiny magnet. Why? Because you know electron is a charged species. Yes, what is the charge of electron? Negative charge. So if a charged species undergo any type of motion means it will create a magnetic effect. So you know electrons are charged species and which are in motion. Which are the two types of motions present in electrons? That is spin motion about its axis, and also it possesses a orbital motion around the nucleus. Okay. So due to these two types of motion, electrons generates a magnetic moment or a small loop, current loop will produce electron. So that magnetic certain value of magnetic moment will be there. That is a small effect of magnetic property will produce in the electron itself. That is why every substance behave as a tiny magnet, or every electron behaves as a tiny magnet, isn't it? So that magnetic moment we can measure by a unit known as Bohr magneton. Okay, and which is represented by mu, and the value is 9.27 into 10 raised to 24 ampere meter square. Okay, so that what I told, each electrons behaves as a tiny magnet. Why it is so? Because electrons are in motion and it possesses a negative charge, and it also have a two types of motion, which are the spin motion and orbital motion. Due to that motion, it produces a small loop of electric current. So which means a magnetic moment will be there, and that magnetic moment we will measure in the unit called Bohr magneton. Bohr magneton, and its value mu is equal to 9.27 into 10 raised to minus 24 ampere meter square. Okay. So based on this magnetic property, substances are classified into 5 categories. Okay, which are they? First one is paramagnetic substances. Paramagnetic. Okay, and second category is diamagnetic. Diamagnetic. And third one is ferromagnetic. Ferromagnetic. And next is fourth one, antiferromagnetic. What is that? Antiferromagnetic. Antiferro. And then last one, ferrimagnetic. Ferrimagnetic. So based on this magnetic property, substances are classified into 5 categories, which are the paramagnetic substance, diamagnetic substance, then ferromagnetic, antiferromagnetic and ferrimagnetics. What is the speciality of these 5 categories we will discuss. So I told you, based on the magnetic property, the substances are classified into 5 types, which are the first one, paramagnetic substances. Paramagnetic substances means they are weakly attracted by a magnetic field. Okay, and also they are magnetized in same direction. And what is the speciality of paramagnetic substance? There is the presence of unpaired electrons. Okay, so example you can see in the case of when you draw the molecular orbital diagram of oxygen, or we can see that oxygen is paramagnetic in nature, because in that case you can see 2 unpaired electrons are present. One or more number of unpaired electrons will be present in paramagnetic substances. Okay. So when you are applying a magnetic field, they are oriented in the same direction of the magnetic field. When you remove the magnetic field, it loses its magnetic power. Okay. So another example for paramagnetic substances is transition elements like Cu plus, Cr3 plus, Fe3 plus etc. show paramagnetism. While checking the electronic configuration, you can see that there is a presence of unpaired electrons. So usually നമ്മൾ സബ്സ്റ്റൻസ് പാരാമാഗ്നറ്റിക് ആണോ എന്ന് എങ്ങനെയാണ് ചെക്ക് ചെയ്യുക? അവയിൽ unpaired electrons ഉണ്ടോ നോക്കിയാൽ മതി. Okay, if unpaired electrons are present, then substances will be paramagnetic. So once more, they are weakly attracted by the magnetic field. The next type is diamagnetic. There is no unpaired electrons present. That means all the electrons are paired. In diamagnetic, all the electrons should be paired one. Okay, and also they are weakly repelled by the magnetic field. മറ്റേ കേസിൽ എന്തായിരുന്നു weakly attracted ആയിരുന്നു, but here it is weakly repelled by the magnetic field. Okay, and here magnetized in same direction ആയിരുന്നു paramagnetically, but in diamagnetic direction they are when magnetic field apply ചെയ്യുമ്പോൾ they are oriented in opposite direction. Okay, so all electrons are paired, there is no unpaired electrons will be there. Okay, and pairing cancel their magnetic moment and loses their magnetic effect. Okay, അല്ലെങ്കിൽ loses their magnetic character. So that's all about diamagnetic substance. Example, you can see lots of examples, that is NaCl, H2O, etc. Okay, benzene, etc. Then third type is ferromagnetic substances. Ferromagnetic substances mean substances like iron, cobalt, nickel, etc. So what is the speciality of ferromagnetic substances? Strongly attracted by the, very strongly attracted by the magnetic field. Okay, and they behave as a permanent magnet. അപ്പോൾ ഈ കാറ്റഗറിയിൽ പെർമനൻറ്റ് മാഗ്നറ്റായി ബിഹേവ് ചെയ്യുന്നത് ഏതായിരിക്കും? ഫെറോമാഗ്നറ്റിക് സബ്സ്റ്റൻസസ്. ഓക്കെ, ഓരോ ഗ്രൂപ്പായിട്ട് അവരെ തരംതിരിച്ചിരിക്കുന്നു. നമുക്കതിനെ ഡൊമൈൻസ് എന്ന് പറയാം. Okay, each domain acts as a tiny magnetic. In unmagnetized domain laanengil they are not properly oriented ആയിരിക്കും. Okay, so ഓരോ ഡൊമൈൻസ് ആയിട്ടാണ് അവയെ അറേഞ്ച് ചെയ്തിരിക്കുന്നത്. ഡൊമൈൻസിൽ എല്ലാം മാഗ്നറ്റിക് ഫീൽഡ് അതേ ഡയറക്ഷനിൽ അലൈൻ ചെയ്തിട്ടുണ്ടാവും. ഇൻ അൺമാഗ്നറ്റൈസ്ഡ് ഡൊമൈൻസ് ദേ ആർ നോട്ട് പ്രോപ്പർലി ഓറിയൻറ്റഡ്, അല്ലെങ്കിൽ റാൻഡം ഓറിയൻറ്റേഷൻ ആയിരിക്കും. Okay, example I told you what is that? Iron, cobalt, nickel, etc. The next is anti-ferromagnetic substances. Okay, so ഇവിടെ നമ്മൾ ferromagneticsൽ they are oriented along same direction ആണ്. Okay, same magnitude, same direction ആണ്. Then anti-ferromagnetic substanceന് example ആണ് MnO. Okay, domains ഒക്കെ similar to that of ferromagnetic, but here in opposite direction ആയിരിക്കും. ഓക്കെ, അതായത് ഇങ്ങനെ ഈ ടൈപ്പിലായിരിക്കും അലൈൻ ചെയ്തിട്ടുണ്ടാവുക. ഓക്കെ, so such substances are called anti-ferromagnetic substances. And the last one is ferrimagnetic substances. Okay, aligned parallel and anti-parallel to magnetic field, but unequal ആയിട്ടായിരിക്കും അലൈൻ ചെയ്തത്. സപ്പോസ് ഒന്ന് ഇങ്ങനെ ഓക്കെ അലൈൻ പാരലൽ ആയിരിക്കും, ആൻറ്റി പാരലലും, അങ്ങനെ ഒരു ഓർഡർലെസ് ആയിട്ടുള്ള അറേഞ്ച്മെൻ്റ് ആയിരിക്കും എന്തിൽ കാണാൻ പറ്റുക? ഫെറി മാഗ്നറ്റിക് സബ്സ്റ്റൻസസ്. എക്സാമ്പിൾ Fe3O4, MgFe2O4 or ZnFe2O4. These are the examples for ferrimagnetic substance. Okay, when you are heating ferrimagnetic substance, what will happen? It loses its ferrimagnetism and come back to its paramagnetic behavior. Okay, so these are the different types of substances based on their magnetic property. So that's all about the chapter solid states. We came to the end of our unit solid state. Okay, then next lot of problems and more questions, previous questions we will discuss in our assignment section. Okay, hope you all understood all the things. Okay, thank you.